Good evening. My name is Nadine Chirija, and together with Tohai Seiji, we're going to take you through our project idea that is generative attention-based mechanism for adaptive and personalized learning system. Well, in looking at the project title, seeing the part of learning system definitely tells us the sector that we're trying to focus on. And for the project, we're focusing on the education sector. And in this sector, research has been made, and it shows that when they're trying to solve the problem, they always focus on the higher education, and it's then that they try to come up with applications for and find better solutions there that they can have personalized learning in the higher education. But the elementary section is being neglected. So our system is to come up with an it's come up with an adaptive and personalized learning system in the elementary section, basically, specifically in the math department, as we are going to see how it's going to operate, how we're going to explain it to you. And the problem that we're trying to solve in this, we're trying to solve a problem that we can term as one size fits all. Well, this problem, the way I can explain it to you is in the learning sector, so most teachers when they're teaching, they tend to think that all learners learn at the same pace. Yet there are always learners who tend to lag behind, and others maybe grasp faster and all that. And this limits them from exploiting their full potential. So with this learning system in the elementary section, we aim at it providing personalized, adaptive and personalized learning in a way that it will have to focus on how the child is learning based on the progress, so that it can change dynamically, that in case the difficulty is so hard and the kid is not progressing on so well, they can reduce the difficulty and all that. And we expect this project to have an impact of reducing the expenses, because someone doesn't now necessarily need a tutor all the time and all that. We expect to provide learning anywhere and at any time. We expect to provide insight to the learners. Okay, this system can provide insights to the teachers and the parents so they can know how the children are moving on. And with this system, the students will be able to learn from their mistakes and so on and so forth as the system keeps on moving. Well, as we have said that we're going to solve a problem of one size fits all based on a machine learning approach, we are looking at four keywords that we shall use, four techniques that we shall use in coming up with this system. The keywords we have: retrieval augmented fine tuning, natural language processing, natural language processing, natural language understanding, and generative pre-trained transformers. Well, in the retrieval augmented fine tuning, which can abbreviate as RAFT, this is a technique that enhances the model training by combining retrieval methods with fine tuning. And this improves on the performance. What do you mean by RAFT? RAFT is going to, okay, in the process, in the system that you're trying to develop, RAFT is going to fetch data from external sources. It will not basically based on what it has trained on. It will also try to acquire information from different sources so that we can provide better performance, because you can't store all the data in the world on one place, because the system will end up crashing in a long time. Yeah, and then we also look at the natural language processing, which is the NLP. Now, this one is a branch of AI that enables machines to understand, interpret, and generate human language. So if a question is given to the system, the model can use this technique to understand, to process and understand what the person is actually talking, what the student is actually talking about, and then it will provide a reply that is okay in human language in a way that they can understand. Then we also have natural language understanding. Now this one, it also enables the machines to understand students' input and provide understandable responses. So it works hand in hand with the natural language processing. Then we also have generative pre-trained transformers. Now these ones are designed to understand and generate human-like text, generate explanation summaries, and so on. So these are, in short form, they're called GPTs. Like how you have ChatGPT. ChatGPT can understand what you've given it, and it maybe generate a question. You can ask it, okay, generate for me these questions, a question about this and this. It will generate for you questions according to your topic and provide for your answers. Maybe it can summarize for you and things like that. So these are the four techniques we expect to incorporate in the system so that it provides the adaptive and personalized learning. Well, as we shall see in the problem statement, we are talking about the two, okay, in the concept paper, we talk about a problem statement. We have a section that talks about problem statement. And the problem statement has two subsections. That's the domain-specific problem and the technical computational problem. So in the domain-specific problem, it's the problem that we're solving in terms of the domain that we've chosen. And the domain that we chose is education. And the problem that as we've talked about, it's the one for one size fits all. This problem is whereby the children fail to reach their capabilities, their maximum potential, because some of them lag behind due to learning at different paces. And then when we talk about technical computation, these are the challenges you're going to face when you're actually trying to come up with this system. And some of the challenges that you're going to face, we have imbalanced classes. So this occurs when some categories of data are overrepresented compared to others. And when this happens, there is unequal attention when the model is trying to learn the behavior. So this one will affect the system in such a way. Then the other technical computational problem we expect that we might face when we're coming up with this system is overfitting and underfitting. Well, overfitting, this is when it learns too much from the test data that you've provided and it fails to generalize. Then underfitting is when it fails to make reasonable patterns, meaningful patterns out of this. So when all this happens, it causes the data to perform, it causes the model to perform excellently when it comes to the test data. But when you deploy it outside to work on the new data, it performs poorly. So that comes up as a reason of underfitting and overfitting. Then we talk about data drift and concept drift. Data drift, it's the changes in data in the distribution of time. And then concept drift occurs when the relationship between the input features and the target variables changes. And when this happens, it makes the system become inefficient because in the long run, as the more you keep training it, the less efficient it becomes. Then we also expect to face challenges of like model interpretability, where the model lacks transparency in a way that someone can fail to understand how it works. We look at a part of scalability, whereby we have a lot of data to keep and maybe new students are coming in, so it becomes a bit hard to expand the system to accommodate all of them. Then we might face a problem of cold start problem. Cold start problem is where the model lacks initial data for the user, whereby remember in this, it's supposed to give you recommendations of, okay, this is too difficult for you based on this. But when it comes to cold start problem, if it's a new user, it will lack where to start from. Then the other problem is real-time processing requirements. Real-time processing requirements are more delays at that very time. So when like it sends a question, it needs to be responded to, and so on and so forth. Then the other problems we are likely to face are few shot and zero shot learning challenges, and then ethics, decision making. Yes, the proposed solutions, we look at integrating NLP, NLU, that's natural language processing, natural language understanding, Raft, and GPTs. And Raft in this case will provide improvements as it tries to access data from external sources. Then for the NLU, it will improve accuracy by trying to understand what they're actually talking about. NLP will also enhance engagements, conversations while handling imbalanced data sets. And then GPTs will support few short learnings, with providing summaries, explanations, questions, and all that. Yes, thank you very much. That's what I had for you.
Okay, hello everyone. I'm going to be taking you through the description of the dataset and what kind of dataset you're using, how it looks like, and how it's going to help us. So basically, the dataset we are using, is called the GSM 8K dataset, or in full form, Grade School Math 8K, which has grade school or elementary math word problems, which are designed to evaluate and fine-tune the models for the education sector in terms of math for elementary students. So in the train sets, we have around 7,473 examples, and in the test sets, we have 1,319 examples. All these sets are in the JSON-L or JSON line format, and they are all in the language of English. So basically, this data set is to demonstrate this data set is going to be in this form. If you check here, for example, you can see each of these data sets contain dictionaries in JSON format, which have a key of question and an answer. So it has a question and then the response to that answer. So the pre-processing steps that will help us in handling this data set is, first of all, we have text cleaning. Text cleaning, basically, it involves removing inconsistencies and unwanted elements from the raw text to make sure that the model processes only relevant information. Then we have tokenization. Tokenization breaks the text into smaller units that the model can understand. So it allows the machine learning algorithm to process these sentences very effectively. Then we have categorization. This is grouping the problems into based on their type. Maybe, for example, we have maybe addition, subtraction, multiplication. So it will help the problem types and maybe apply appropriate learning for these models to understand. Then finally, we have data splitting. So when we are ensuring generalization, we have to do data splitting. So we have the training set, the validation set, and the test set, where the training set takes 80%, and then the validation and the test sets, which take 20%. So in the next steps after doing the EDA, what do we have to do? We have to do system development. So we have to continue developing this system. We have to introduce GPTs and also improve on the natural learning processing, natural language understanding. Then we have to expand the data set with maybe more challenging math problems than the ones we have in our current data set. Then we conduct a pilot testing with elementary students, and then we gather feedback from the users of this model. So the current research trends we have is integration of machine learning. So in this format, we know that in elementary learning we are going to integrate this machine learning here. So we can finally use this model to integrate it within maybe in a chatbot which the students can use to interact with this education model. Then in the future, maybe we can focus on higher education, maybe deal with harder subjects and harder concepts in math. Then we have adaptive learning systems. We have to address the limitations and maybe personalized learning. So we will have to look at how does the student learn what he needs or what he or she wants to learn, and maybe we can work on our model to make sure that it only works on what the student wants. Thank you for listening.
Thank you very much. This was Group 15 presenting to the project. Yeah, thank you for listening.